Hi, my name's Horton and I'm an application engineer for our 3D documentation team here at FARO UK. During the course of this week, I've been attending an online training session for our new FARO Reality product, where we go through looking at crash scene simulation and accident reconstruction. During the course of the training, I've recorded several small snippets of the training exercises which I'd like to share with you. The first movie we're going to look at is where we look at how we modify the steering and suspension of a vehicle going around a corner. The next movie is looking at an accident reconstruction where we import real-world measurements taken with a total station from an accident scene. We then use the library objects to reconstruct the accident as it would have happened. Next, we looked at how we were going to demonstrate in rolling a vehicle. So in this example, what we've done is created a 2D road, put a slight curb in, and then rolled the vehicle on impact with the curb. Taking that one step further, we've downloaded a Google Earth image which is fully scaled within the system, and then we apply once again total station data taken at the crash site to create topographical information from the Google Earth information. We then simulate the crash, and as you can see, the vehicle follows the terrain. Looking at bullet trajectories next, we had an entrance and exit wound on the window and the back wall of this particular building. The vehicle that we've used was used to simulate a drive-by shooting, and as you can see, the vehicle accelerates up to the scene, fires the shot, and then accelerates off. In this example, you'll see where we use a point cloud to reconstruct the accident. So we select the area around the car, use that information to generate the model, then re-import that model and put it in its start location and its end location to simulate the crash. Earlier in the year, and if you've paid attention to our YouTube channel, you'd have seen that we scanned a crashed VW Polo that had a disagreement with a tree. The link is on the screen now, but I thought I'd show you this movie before we show you how I've gone through and done some of the simulation work. So this is the crash simulation of the Polo. As you can see, it approaches the tree roughly at about 30 miles an hour, gets into a skid, then slides directly into the tree. We've also put the impact damage on the side of the vehicle as well. Taking that one step further, we've exported the Polo data from FARO Scene as a PTS file. We then bring that into reality and we overlay that data against a model within reality of a similar vehicle, and then we simulate the level of damage, and whilst at the scene it was estimated that the vehicle was only doing 30 miles an hour. In the software we've proved that by doing the analysis work. So this is just a very brief movie to show you how to calculate crush analysis within ARAS 360. What I'm going to do is take an existing point cloud of a vehicle that I scanned earlier in the year, which was a VW Polo involved in quite a horrific crash, import that in meters, take in 100% density of the point cloud, and when that's done you'll see that the vehicle and the damage that occurred to it. So all we'll do is rotate that around into a view that we can see. Then I need to go to the library, and before I do that I'm just going to turn off the point cloud snap, go to the model library and import a similar vehicle, which down at the bottom here we should have a VW Polo. I believe looking at the years of the two that this is a slightly newer model than this, but for the purposes of this video it will give us a good impression. And then all we need to do is try and position one model over the other, which is quite difficult considering the nature of this particular crash. But what I'm going to try and do, just try and line up the front and the rear, is try and pick up the main area here where the wing has moved forward and the main area here where the wing has moved backwards, because you can see the damage in the middle. Once we've got that, we go to create volume damage, and I don't want to calculate the whole of the car. What I want to focus on is just behind the front wheel and just in front of the back wheel, so this main area here. We also only want to look at the front damage on the left hand side. When I've got all that, I click determine damage. The system will go away now, compare a mesh of the two, and then tell us what damage has been given. And here straight away, according to the data that we've got, the BEV, or the barrier equivalent velocity, reckons that it came out at about 30.44 miles per hour. So all I'm going to do is rotate this around, position it nicely on my screen, zoom in a little bit, take a snapshot and print the report. And straight away we can see we've got a nice tabulated report with a view of the two vehicles and all the data at the bottom. Thank you for watching. I hope it's been of use, and please feel free to look out for forthcoming movies.